Moving on to the final join stuff. We've covered a whole bunch of stuff, and today is the weirdest thing of all, self-joins. What I have here is these files. You can download them whenever you want. We're going to download this one. So you click on it, and then you come here and click on it again, and it'll actually download it. And then I'm going to go back one page and download the other one. The other one, it's just some of the queries we're going to write today. Okay, so download that. The first one, though, that we downloaded is actually an install of a database called generic company. So friendly reminder, you type source, space, drag it in, hit enter, and bam, it creates the database. Make sure some computers, when you drag this in, it automatically puts quotes around it. Make sure there's no quotes when you run that command. But other than that, we have this nice little database here. Now it's called generic company, show tables. That's it, one table. Okay, so we're going to do some stuff with this table, which is really weird. And before we actually do it, though, I want to make sure that we convince ourselves that the only real way to do this is with the self-join.
You know what that means? It's Latin. Means know thyself.
Like, could we restructure the tables to work a better way? And we're going to find that the answer is no. Now, you guys might come up with a solution that's we've never come up with in my other classes before. That's totally possible. But we're going to take some time walking through that, okay? Meanwhile, let me show you another table that I have. Use discrete math and select star from alphabet. This is a list of every letter in the alphabet, right? A through Z. So I'm going to give you a math problem here, a discrete data structures problem to be more specific. That has to do with a couple of ideas. One's called the Pigeonhole Principle. And if you haven't heard of that, that's fine. But the reason I want to do this is to give you a use case where A, a self-join is useful, and B, a Cartesian product is useful. This is going to be a Cartesian product of a self-join that makes a Cartesian product. So here's the question. How many people would you have to have in a room, an infinitely sized room, to guarantee that at least two people have the exact same initials, first and last name initials? How many people would you have to have in a room to guarantee that at least two of them have the same initials? So while you're thinking about that one, I'll give you a different one that's the same concept that's a little easier to think about. How many people would you have to have in a room to guarantee that at least two of them had the exact same birth date? Not year, but just month and day. To guarantee. Like right now, all of us might have the same birthday, but that's not a guarantee. But there is some number of people we could put in this room, if we could fit them, that would guarantee at least two. Say again?
366.
One more.
7?
Yes, why?
Oh, leap year?
Leap year, yeah, very good. So the answer to that question is 367, because if I had every single birth date represented in this room, I have one guy with January 1st, one guy with January 2nd, all the way up to December 31st, including February 29th, right, the leap year, that's 366 people. The moment the next person walks in the room, it has to be a duplicate of somebody else because I have every single birthday possible in the room, right? So with that in mind, what would be the question again, how many people would I have to have in a room to guarantee that at least two people have the same initials? So what number, maybe we don't know the actual number, but how would we get the number? Because I could pair the letter A with A through Z. I could pair the letter B with A through Z.
677?
To 26 squared, right?
Yeah.
26 times 26, okay? So so what's the number of people you'd have to have in a room to guarantee that two people had the same initials? What is it? It's not the number she said. Plus one. The plus one is where the pigeonhole principle comes in. So 677. Yeah. What's the pigeonhole? You don't need to know for this class, but I'll just tell you briefly the idea. The idea is if I have more pigeons than I have holes to put them in, at least one of the holes will have more than one pigeon in it. It's pretty like a no-brainer, right? If I have 5 pigeons and I've only got 4 pigeon holes, one of those holes is going to have at least 2 pigeons in it, right? That's all it is. So in this case, with the number of initials, those are all the pigeonholes, and I have one more number of people than I have holes. And so that last guy, that 677th person, will be sharing with somebody else's pigeonhole, which is their birthday or their initials or whatever. All right. I don't tell you that because this is a discrete math class, because this is not. It's a database class. But they're fun problems to think about. But you can solve these kinds of things with code, or in this case, we can do a quick little query in a database. And in fact, I use this database in my discrete math class for this purpose. So how would I be able to pair up every letter of that table with every letter of that table? It would be a self-join, first of all. Okay, now let's imagine that I had two separate tables, because we don't know how to do a self-join just yet. So imagine I had two separate tables. I had table A that's got A through Z, and I got table B that has A through Z. How would I get every possible combination then? Cartesian product of the two tables, right? Well, we're going to do a Cartesian product real quick, which we looked at this the other day, right? So that table is called alphabet, and the field is called letter. So we're going to do a self-join that's also going to be a Cartesian product. So I'm going to do select. What I really want is the results to be letter next to letter. Like I want AA and AB and AC, right? That's what my results are going to be. So how do I get two fields right next to each other? We've done this before. Like if I wanted to say first name and last name stuck right next to each other, what do I do? Concatenation, right? So I want to concat letter, which is a field name, with letter, right? You agree that's what I want to do? Yeah? Okay, so there's something wrong with that, but we'll come back to that. From the letter table, let's get some syntax highlighting here. Join the letter table. That's the entire query right there, because now we got to modify a couple little things here. But remember, a Cartesian product, there's no on clause, right? And there's no where clause if you're doing the common syntax. So this is actually what we're looking for. Would you agree that that's the idea there? So in other words, imagine if I did have those two tables, and they literally were called table A and table B. And it would be from A, join B. That would do it. That's not a self-join anymore. That's just a Cartesian product of two separate tables. Well, it's almost that simple. We're just going to go letter as A and letter as B. The end. That's a self-join. All I did was alias the letter table to be called A in that scenario and B in that scenario. Now, because we're using letters, that might be confusing, so let's maybe give it a little bit better name, like letter 1, letter 2. But A and B will work just fine as well. Letter 1, letter 2. And maybe I should call it alpha 1 and alpha 2, because that's actually the name of the table. This should not be letter here. That's a mistake on my part. That should be alphabet. Sorry. The table's called alphabet. Sorry about that. Did I screw you guys up by doing that mistake? We good? Sorry. That the whole time that should have been saying alphabet there, not letter there. That's the name of the table. Okay. Yeah, we would have found out in a minute when we did that. So maybe we'll call them alpha 1 and alpha 2 or something like that, right? All right, hopefully I didn't mess your brain up too much there. And there we have every single pairing of every letter with every letter. And you'll see it ends with ZZ. It started with AA, then BA, CA, DA, all the way down to ZA. Then we got AB, ABB, CB, all the way down to ZB somewhere right there. And then AC and so on. But it's every pair. And the total that we saw a minute ago is correct. It's 676 rows. But that's a Cartesian product and a self-join. Now, in a minute, we're going to do a self-join that has an on clause, which is way weirder. The syntax isn't that hard. What's hard is wrapping your brain around the syntax. And that takes maybe years sometimes. It took me forever to get my head around a self-join. But not everybody's as slow as I am. Maybe you'll get it quicker. I don't know. All right, so let's take a look at this data here before we actually do the self-join. Let's make sure we understand it. So my name is Beth Peterman. Who is my boss? Mona Kanzler. Yep, right. My name is Beth Peterman. My employee ID is 366. My manager's employee ID is 198. Well, who has employee ID 198? Mona does. So that's my boss. My name is Matt Trainer. Who's my boss? Benito Galvez. Yeah. My name is Morgan Witzler, who's my boss, or Wiltzer, sorry. Mona, yep. My name is Martin Holder, who is my boss? I don't have one. Maybe I own the company. I don't know. I'm not sure why I don't have a boss. Okay, so the idea here, you guys just did a self-join in your head. You realize that? You just did a self-join in your head. What did you do?
What'd you do?
Well, let's see if we can work this out. I told you that my name was Beth, and so what did you do? You joined this foreign key, 198, to this primary key, 198, right? So that's all we did. Did everybody see that? That's what happens when you do a regular join. You're looking in a different table, getting the foreign key from table A to link up to the primary key in table B, and you bring in that data and you bring the two together. That's all that's going on there. So I need to write a query that will display these kinds of results. I want a query that says employee name is blah, 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 and their boss is so-and-so. So here's a way to think about this that'll maybe help keep our brains a little bit straighter. Now, there's only one table here. There's only one table. It's called employee then. There's no other tables, okay? And we're going to walk through this table in a minute and see if we can come up with a better solution. But for the moment, we have employee number, last name, first name, and let's just go with, we'll call this the employee table, which I think is what it actually is called. So now it's clear that that's the primary key. This is the foreign key. Let's make this table like the manager table, right? And so they don't have this. And maybe this is like, the manager num or something like that. And we just make this say manager num. Now, if I gave you that, you guys could join this in your sleep. It's a regular old join, right? I would just say join employee on I'd select star from employee, join manager. So let's just write it instead of trying to say it out loud. If I wanted to do that one, I'd say select star from employee, join manager on manager.manager num equals employee.manager num. That's really no different than our select star from customer, join rep on rep.revnum equals customer.revnum. That's the same thing, right? But everything we just did on the screen happens in your brain, not in the code. So you have to see that visual in your brain when you write a self-join. Whereas any other time you do a join, it's all right there for you. You just look at the tables and it's there, right? But in this case, you got to think through all this in your brain. Okay, how do we feel at the moment right now? We good? Okay, I want some sort of output that looks like this. Beth, whatever her last name was, and it's going to say Mona. And then the next line, so on down the line, right? Would you agree that the only way to get that output is a self-join with the current structure we have? If this is the only table I have, is there any other way to get this data other than joining it to itself? Not in a way that I know how. The question was, could you do a subquery? There may be a solution for it with subqueries. I just don't know exactly how I pull that off. Maybe several deep, I don't know, it'd be weird. Yeah. But I want to make sure we're all on board, right, with the structure we have now, right? I haven't shown you other structures, but with this structure we have now, can you fathom any other way besides a self-join? We thought of a subquery, but it doesn't seem to work. I'm going to vote for it's the only way. So I promise we are going to write the self-join. Okay, we'll get to that in just a minute. But the next thing I want to do is I actually want us to see if we can come up with a better table structure than this. And maybe more tables or maybe some other structure so we don't have to do a self-join. Because right now we all are in agreement that it seems to be the logical solution to do a self-join. So I'm going to open up a spreadsheet here. And let's take this and let's try to map out the tables like that. If we were going to build a new version of this database, what might it look like? Let's talk through this. And I want to spend a couple minutes on this. But what do you think? What can we do? So we have an employee table. Okay, we'll start there. Okay, so there's our employee table. It's pretty sweet. Now what? Make a manager table. It's going to be kind of similar, right? So what's their ID going to be? we don't have to use the numbers here because we're making a new table, so we can do whatever we want. So we want to just go like 1, 2, 3, or what? Is that good? I don't want to lead the witness, so I want you guys to do this. Okay, now what? One employee probably only has one manager, right? But one manager could have many employees, so that looks like a one-to-many to me. So basically, we recreate this exact table, right? ID, name, manager ID, right? We could do a bridge table if we did have a many-to-many, where in case that happens. But let's just do it this way. This seems reasonable. And so we can, right off the bat, we can say that Mona is, let's just do this here. Here's a cheap way to do this. Paste those in right here. And then we know that 108 is 1, so we'll change all the 108s to 1. And we know 198 was replaced with 2. You guys follow what I'm doing there? Yeah. Just putting in the numbers that match over here. Okay, so that seems reasonable. We'll call that manager ID table or something like that. Finish that there. Are we done? We got more to do. Think we're done, you said? Yeah. So if I wanted to do a display that showed every employee with their manager, could we do it? Leaving aside the null one, the Martin not having a name, let's say everybody has a boss, just for the moment. Let's just put a number there. Let's say everybody has a boss. Could I get all the data I need? Can I get a display that's got employee on the left and manager on the right? Yeah, because that's what I did a minute ago, right? Where I broke this out and pretended like it was 2 tables. That's essentially what I created, was this exact thing, pretty much. So that being the case, I'm going to tell you this is a bad idea. I want you to tell me why, though. Don't feel bad. This was not me like saying, oh, you guys screwed up. That's not what I meant, right? It just, there is a problem with this structure, and it's the same structure that every class comes up with. It's the only structure I could think of when I try to figure out a different solution. It's very common that this is the way we think to solve it. So what is wrong with this? There's duplicate data for sure. Martin Holder has 2 IDs. He has ID number 1 and ID number 108. So let's take this to a real world scenario. Let's say I worked as a secretary in the AD's office. And let's say that Slick, the Solid Community College here, ran their tables like this. So I'm in the administrator's database as an employee in the administrator. Then maybe I decide to no longer do that, and maybe I've got a degree, and so I decide I want to start teaching. So now I'm in the faculty database and the administrator database. Maybe after getting tenure, and I've been here for a dozen years, I decide to try to become an AD. And then now I'm in the AD database. And then maybe after another 15 years, the dean position comes open, and I try to get that job, and now I'm the dean, and I'm in the dean database, right? So where should I have been removed from the other databases ever? Should I stay in all those? Do you delete records? If I delete records, what does it do to other reports that are based off of those things? So it can get pretty messy pretty quickly, right? And on top of all of that, let's say I decide to follow my dream and change my first name to Elvis, like I've always wanted to. Now you have to change it in 5 different databases. No, the truth is, if I ever changed my name, I would change it to Dave. Because once a year, Famous Dave's restaurant, you get a free meal if your name's Dave. So if I ever changed my name, I would change it to Dave. I'd still go by Jeff, but my official driver's license would say Dave. Hey, that's barbecued meat for free? Come on. Okay, so would you agree that this maybe isn't necessarily the best solution, right? That it's got some redundancy here. And in a real scenario, maybe somebody gets married and decides they want to change their name when they get married, and you have to change them in multiple places. So what it comes down to, here's a really good rule of thumb. If you have to change a raw value of some data in more than one place, you got a bad structure, right? If I need to change the name of a product and I have to change that in 5 different tables, that's bad. You should have a product in one table, and every other table maybe has a foreign key that links to that one. But any report that displays a product name is coming from the one source, the product table. Maybe I need to change the employee name, that's fine, but if I have to change it in 5 different tables, that's a problem, okay? So I'm gonna vote for, we're stuck with a self-join. What do you think? I know that was a long drawn-out process, but I do that for a reason. The reason I did that is because I want to convince each of us that there are real-world scenarios where you have to have a self-join. You see something like this and you're like, well, crap, there's got to be a better way to do this. And I really don't see another way to do it and where it doesn't violate something, redundancies in normal form or something, right? So there's no real way I could see to do it. Okay, let's do the actual self-join. You ready? Let's do it. And now I could leave the other table there for reference, the other, air quotes, other table, right? But I want it to not be there because we have to see that in our brain. So let's start off here. What I really need, and let's go to here. I will put this table in there for reference. So let's just move this right there. Ooh, that's fancy.
You know, I might have been born just plain white trash, but fancy was my name.
Right here, we know we want something like this. We want select concat first name, comma, last name. That's for the employee. And then we want that exact same thing for the manager. That's the manager, that's the employee, right? And it's gonna be from the employee table, join the employee table, right? On something. We'll talk about the on in a minute. But do you get that's what we gotta do? Right now, this is weird, right? What does that even mean? You can do that, by the way, that's legal. This is totally, like I can do this like without a join here. I can totally do that. It's just gonna put the same fields in both, same data in both places, right? Because it's looping through and it's like, oh, he wants to, for some reason, print the first and last name twice. I don't know why, but he's doing that, right? So that's not weird. This part is weird, and what's weird is I don't know if that's the employee or the manager. So let's start there and just alias this as employee, and we'll alias this as manager. So that's a little cleaner. Now this data is broken. This is not right, but at least it kind of looks the way we want, right? But that's invalid data. Okay, well, that means that this is coming from the air quotes employee table, right? Let's just call it E for employee. So I want to pull from the employee table, and then from here, I want to pull this out of the manager table. Again, air quotes around manager, because there is no such table, right? But we're sort of tricking SQL into thinking that there is. Not really, but that's a good way to think about it, right? So now we're calling the employee E, join the manager table, like so. Now, if I stop right now, we'll have a Cartesian product, and this is it's useless data, but it is a valid join, right? Right, we get every combination, which makes sense because there are 10 records, and 10 times 10, that's 100. So we just paired up everybody with everybody, so that's a Cartesian product, which we do not want in this case, obviously. But now we just have to write the on clause, and the on clause isn't that bad, right? So I'm joining on the manager table, m dot what? This is where it gets weird. So typically, yeah, so what we're looking at, remember, we're taking the foreign key and joining to the primary key, the foreign key of one table. So, for example, the customer table in our normal databases, right? We want the rep num, that's the foreign key, and we want to join that to the primary key, rep num in the rep table. So what's the primary key that we're going to be pulling in? Yeah, it is the employee num from the manager table, right? So it's that employee num equals the employee what? Managers, and this would be better named if it was manager's employee number, right? Like it's possessive, but I just did it that way, okay? So that's correct. We'll do manager emp num. That should give us what we want. And now let's do select star from employee just to do a little sniff test here, all right? So is Mona's boss Martin? Mona, Martin, yep. Joan's boss also is Mona. So Joan is 198 and 190 is Mona, right? Let's do one more. Do Matt Trainer, his boss is Benito, and Matt Trainer's 301, and yeah, boss is Benito. So the pass the sniff test, it worked. That really is it. The self-join is super easy as far as like the syntax is not crazy, messy or anything. It's just hard to think about. Okay? So I'll give you a little tip, and I've given you this tip before, but it probably wasn't as important as it will be right now, all right? Here's the tip. When I write a join, so let's just move all this crap off the screen for just a minute. When I write a join, I've told you guys this little trick before. I say select, let's just go with the typical customer join that we do, customer.customer num, and we do customer.customer name, and then we do rep.rep, or sorry, last name, something like that, right? Pretty standard join. We've done this before a bunch of times. Then I say from, and then I'll do the customer table because that's sort of the main table where all the data is coming from, right? And think about it in these terms. Why is customer the main table? There's no such thing as a main table, right? It's just in my head. But why am I saying it's the main table? Well, because I'm displaying customer data and I want to know who the rep is. I'm not doing a thing where I'm saying I want to display reps and see who their customers are. I want to see customers and who their reps are, all right? So I put that one first, and then here's the little tricky part. I type join rep, and the next thing I say on my on clause is the table I just wrote, rep. That was the trick I taught you guys the other day. So join rep on rep, just spit that out, join rep on rep. Or if it was the other way, join customer on customer, right? Whatever, and of course I'm going to finish that with the primary key, rep num. So it's whatever table that's right after the join on its primary key. Just if you get in the habit of saying join rep on rep or join, you know, whatever, table A on table A dot whatever, right? Whatever it's called. Then it's going to equal whatever the foreign key is. Well, what's the foreign key? Customer dot rep num. There you go, right? Good. That's a pretty standard join we've done. Well, let's look at our other query here. And put it right here. And look what happens here. Let's change these names to something a little bit more useful here. We'll call this the manager, the MGR table. Right? And for just a minute, I'm going to leave off the real word employee there. So I'm saying from employee, join manager on manager dot whatever the primary key is, which is employee num, right? Equals the foreign key, which is employee dot manager employee num. That's it. Now I have to put the real table name in there, of course, but so employee as and employee as. But that's exactly what I did a minute ago. I just said join or from employee E or as E, join employee as M on M dot primary key equals employee dot foreign key. What may throw you off a little bit on this particular example is the fact that in this scenario, for obvious reasons, and I'll tell you if you don't see it, I'll tell you what that obvious reason is, but the foreign key cannot have the same name as the primary key in this case. Why? Normally, like rep num in the customer table is the same as the primary key rep num in the rep table, right? Why can't we do that here?
There's only one table.
Yeah, because it's in the same table, right? So I can't name that field also employee num because that already exists in that table, right? That's the only reason it's got a different name, okay? But there's no rule that says that foreign keys have to have the same name as primary keys. In fact, in my tables, they never do. When I build my own databases, my foreign keys never match the name of the primary key, ever. Never. All right. So, one last thing we could do here if we wanted. Let's make sure I didn't break my query here. That looks like it's the right data, all right? Now, we don't notice the problem, though. There's only 9 records showing. How many employees do we have? 10. So how do we fix that problem? You said it a second ago. Yeah, an outer join, right? Very good.
Oh, nice.
Well,
20 minutes.
same thing.
All over the place.
Moments ago, we'll go with that, right? Now, what do I want to do? I want to display everybody in the employee table, even if they're not in the manager table. Is that what I want? Even if there's no record matching it in the manager table.
Yes.
So is this a left join or a right join? Left join, right? Because I want to show everything in the left table, even if there's no matching record in the right table. So left join the end, and we will now have this, and it has null for Martin, and so let's go ahead and concatenate that, or coalesce that. And we'll coalesce it to say no supervision needed. I was going to write no supervision necessary, but it is impossible for me to spell necessary. So I just wrote needed. That's how I get around that one. And there you go, no supervision needed, okay? All right, any questions about anything we covered today? If you want, I will, because I saw a puzzled look on your face when I said my foreign keys never match my primary keys. I will happily add that to this video if you'd like me to, what that's all about. But are there any questions about this self-join business? This is it, guys. We're done talking about joins as far as learning new stuff goes. Moving on next week will be all new topics, right? I spend the most time on joins because you'll do it a lot in the real world, right? It takes practice, okay? All right, questions? You want to see the other thing that I'm talking about? It's not that big a deal. If I were to design a table, like let's design the customer table real quick and the rep table. Here's how I would do it. This is the customer table. And I'm gonna not have all the fields because we don't have time for that.
Ain't nobody got time for that.
But I'd literally call the field ID. And then this would be name, and then we'll just go with city. That's all I'm gonna have for now, okay? But that would be my customer table. Obviously, I'd have more fields, address, and blah, blah, blah. And then I would have my rep table, would have primary key as ID, and it has, last name and first name, right? That's my rep table. So there's my rep table. Let's label these. My foreign key here to link my customer table to my rep table is called rep ID. That's it. That's how I do mine. Every one of my primary keys is called ID in every single table. Every table I call it ID. That's the primary key for all my tables. And then the reason I do this is so that I don't even have to think what the primary key is. I never have to think about it. I always know it's ID, right? It's always ID. And this I don't have to think about either, because I really do it like that, because this will always be the table name followed by ID. So whatever foreign key, whatever table I'm joining to, it's right there in the name, rep ID. So I know exactly what I'm doing. This is joining, whatever's in here will be the primary key that's over here. That's how I do all of mine. That's relatively common way to do it, but it's not the only way. All right, folks, anything else? Then you shall have a groovy weekend.